population of the United States with each of these blood types is summarized in the following table. So O is about 45%, A is 40%, B is 11%, and AB is about 4%. So use this data to answer the following question. The blood types and the proportions given in the table above define a probability distribution. Okay, a probability distribution. I remember reading this actually. I just don't need to find it again, find the definition.
Yeah.
I think that's what it is, but I think it's true. But I won't under.
It sounds like it, but
I mean that to me honestly I would say true, but if you want me to look it up I can. Because it's portions and the probability. Yeah, I can keep looking real fast though, just so we can make sure. I need to get 100% on this. Okay, so probabilities follow patterns called probability distributions, or distributions for short. There are 3 rules that a probability distribution must follow. Answer the following questions to discover what these rules might be. Okay, so the rule 1 is the probability of an event X is a number between 1 and 0. Or sorry, 0 and 1. Rule number 2 is if you list all the outcomes of an experiment, such as rolling a dice, the probability that one of these will occur is 1. In other words, the sum of the probabilities of all the probabilities comes up. Okay, yeah, so that's true. So rule 1 and rule 2 apply, and rule 3 is the complement rule. The probability that an event X will not occur is 1 minus the probability that it will occur.
Okay, so yeah.
Yeah, so I'd say true. Okay. So what is the probability that a randomly selected person in the United States has a type O blood? Round to the 2 decimal places. Wouldn't that just be 0.5%? I mean, or 0.45?
That's what I was thinking.
I mean, that sounds too simple. I feel like it's a trick question, but I'm pretty sure that's what it is.
Yeah.
Because 40, so that's 85, 89, 100. So yeah, that's out of 100. 0.45. Okay, so what is the probability, so number 5, what is the probability that a randomly selected person will not have type O blood? So it's 100 minus 45.
0.5.
Yeah, so 0.55. Popular blood type, okay. Okay, so number 6, are you okay with me reading and is that okay? I just don't
that's fine.
Okay, just to make sure I'm not taking over. Okay, so Carolyn Willis and her colleagues conducted a study in which dogs were trained to detect bladder cancer. The dogs were trained to lie down next to a specimen derived from a bladder cancer patient. Tangle, one of the dogs, demonstrates the identification of a specimen. 7 bowls containing urine were lined up in random order. 6 of the samples were from patients who did not have bladder cancer. 1 of the samples came from a person identified as a bladder cancer patient. Answer the following questions. If the dog guesses at random, what is the probability that they will correctly identify the dish containing the specimen from the bladder cancer patient? Round answer to the 3 decimal place. Isn't it just 1 out of 7?
Yeah.
So that would be just for a decimal. Why don't you just divide 1 by 7?
Yeah.
Okay, so 1 divided by 7 is 0.1428, and it says round to the nearest 3 decimal places. I'm always really bad at this. It's 1.43 then, right?
Yeah.
Okay, just making sure. Like whenever I have questions, I'm always like 1 off, and then I get it wrong.
I know, I hate that.
I know, anyway, it always happens. I feel like they're so finicky sometimes. Okay, so number 7, in a combined total of 54 trials, the dogs correctly identified the specimen from the cancer patient 22 times. It is very unlikely that the dog would do this well by random chance alone. Which of the following statements is most appropriate? This provides strong evidence that dogs can detect bladder cancer. There is little evidence that dogs can detect bladder cancer. All right, well, 22 divided by 54. So the dogs got it 40% of the time. They got it right 40% of the time. So this provides strong evidence that dogs can detect bladder cancer, or there's little evidence? For me, I feel like there's little evidence.
That's what I was thinking.
Yeah, because I mean, less than 50%. That could just be guessing. That's just luck.
Yeah, and so, even if it wasn't, I don't know.
Yeah, I know what you mean. Okay. All right. So number 8. M&Ms are small chocolate candies. The M&Ms website previously indicated that in the United States, the distribution of the colors in the bag of plain M&Ms is given in the following table. So brown, there's 13%. Yellow, there's 14. Red, there's 13. Blue, there's 24. Orange, there's 20, and the green is blacked out. If you reach into a bag of plain M&Ms, what is the probability of drawing a red-colored candy? Isn't it just 0.13?
Yeah, I think so.
Or because those numbers don't add up to 100.
I think that's why the green's blacked out.
Okay. So we don't need to okay. Yeah. So just 0.13. Number 8, what is the probability that a randomly selected candy is green? So we just need 100 minus all those numbers. 13 minus 14 minus 13 is 24 minus 20. So 16.16. So is that what you got?
I haven't finished it yet.
Yeah.
Point 16.
Yeah, that's what I got. And then for number 10 is what is the probability that a randomly selected candy is not green? So I just subtracted 16 from 100 and I got 0.84 for number 10.
Yeah, did you get 0.84?
Yes. Okay, so you ready for number 11?
Yep.
Okay, so the ACT scores of the students admitted to a medium-sized public university in the Western United States was taken from Capex.com. The following summary statistics were calculated. Okay, so all of that information. Use the information from the public university to answer the following questions. Half of the observations are less than or equal to what number? Wait, what?
So wouldn't we look at the median?
Because it's the middle number, so 24.
Yeah.
Okay, so wouldn't it just be 24 then?
Mm-hmm.
Because it's asking. Okay, that confused me more than it should, but it didn't. Okay, based on the information on the table below, the top 25% of the students scored above what number? Oh, isn't that well, the max is 35, so that's the best someone did, right?
Yeah.
And then, but the top 25%, isn't that quadrant 3?
Yeah.
So shouldn't it be 27?
Mm-hmm.
Is the information okay? Ooh, I'm getting this. All right. All right, number 13. Which of the following statements is not one of the 3 rules of probability? Oh, I think I read this, didn't I?
Yeah.
So the probability that an outcome will not. Well, do you want me to read it to you, and then you can say which one is not there? So rule number 1 is the probability of an event X is a number between 0 and 1.
Okay.
And it's rule 2. If you list all of the outcomes of an experiment, such as rolling a dice, the probability that one of these outcomes will occur is 1. In other words, the sum of the probabilities of all of the possible outcomes of any experiment is 1.
Okay.
And then rule 3 is the complement rule. The probability that an event X will not occur is 1 minus the probability that it will occur.
Okay.
So which one is it not?
It's not. If the probability is high, then the probability is positive.
Yeah. Okay. Yeah, that's it. All right. So we feel good about this?
Yeah, I think so.
Okay.
Seems really easy
though. Yeah, I know this is pretty simple, but I needed something simple today.
Yeah.
So I'm submitting it. Yeah, we got one wrong. Oh, the dog one. That's interesting. I thought the same thing. Yeah. I'm surprised we got that one wrong, actually.
I thought maybe it was a trick question, but I wasn't
I
sure.
know. I don't know. Yeah, me too. I don't know. Oh well, it's okay. We still did a good job.
Yeah.
All right. So are we good then?
Yeah, I think so.
I mean, they never showed up. I don't know. So you're gonna post that link, and then maybe I sent you a group email. Did you get it?
Yeah, I did.
So you have their email. I'm sorry, I'm making you do it, but maybe do you want to email them the link of our group session and just say sorry we missed you, or should we just leave it?
Well. I guess we could let them know that we did it, and then they can do the quiz and check it of ours or something.
Okay. Yeah, sounds good to me.
All right.
Well, thank you.
Thursday at 4:30.
Yeah, let's just keep it consistent and just do that each time.
Yeah, I like that.
Yeah, it'll get way too crazy if we try to move, try to different times each day. All right, well, have a great day.
Yeah, you too.
Finish everything you need to do. Okay. Bye-bye.